Were you wondering what this little piece was that came in your kit? Well, you're finally in the right place to figure out just what it is and how we're going to test your bridges. Let's get right into it.
The first step is we want to get some numbers. Let's weigh our bridge and jot that number down.
Next, let's move some tables or chairs together so we can suspend our bridges over them.
Here's our testing mechanism, which we are going to be attaching to our bridge and loading down with weight. Remember to save a space for it when designing your bridge.
You can connect this piece to the top or the bottom of your bridge, wherever it fits better and makes most sense.
Grab the handle of your bucket and attach it to the bottom of the hook. And check out how the whole testing setup should sit. Ideally with the bucket only a few inches off the ground, so when it does fall, it doesn't do too much damage. What are you going to weigh your bridge down with? Is it textbooks, rocks? Whatever you choose and whatever fits in the bucket, try to get some numbers down of what things weigh before, so as you add them to the bucket, you can keep a running tally of how much weight your bridge is holding. Go ahead and start loading your bridge, ideally when nothing's swinging around or moving. These slow motion shots are always cool to look at, and we encourage you to film the testing of your bridges if you have a camera available.
It would be a piece of cake for a civil engineer to find the strongest material in the world and build their bridge out of a bunch of that material. But can you pause this video and think about why they don't do that, and why instead engineers rely on these efficient truss structures to build their bridges? If you said anything along the lines of, it would be too expensive, or unrealistically heavy, or maybe construction would take too long, you're exactly right. And that's where the principle of structural efficiency comes in, which tells us how much more times weight your bridge held than it weighed itself. Feel free to end this video here and get started on your bridge project. But if you're up for a bonus challenge, come on back here when you're ready, and we'll show you how to calculate your own bridge's structural efficiency. All you do is divide the weight that your bridge held by the weight itself.
This bridge only weighed 0.013 pounds, but it held 13.6 pounds, which gave us a structural efficiency of 1,046.
So now you should be all set. Feel free to decorate your bridges or have some fun with them. But remember, a big takeaway from structural efficiency, and a good rule of thumb in engineering in general, is don't add anything that adds weight and doesn't serve a real purpose.